All right, y'all. Today we're going to be talking about transformations of quadratic functions. So we've talked about graphing quadratic functions and what their key features are. And then we've also talked about different types of quadratic functions. So our vertex form, our standard form, and our factored form. Today, we're going to talk about how we can change our basic quadratic functions using transformations. So shifting them around and stretching them out, making them bigger or smaller, that sort of stuff. So for today's notes, to make it a little bit easier, over on the left side for each of them, I've included what our parent quadratic function looks like, which our parent is just our original. It's our basic one, our y equals x squared here. So just like this is our parent function. Okay, and then over on the right is going to be where all of our transformations fall. And we're going to talk about 4 different transformations with 3 different letters, so A, C, D. What you might also notice about this is that this is already in vertex form. Okay, so all the transformations we're going to be talking about today are going to be occurring in our vertex form. We're not going to do transformations with any of our other forms. All right, so the first one we're going to talk about, we talked about a little bit when we looked at our functions last time, is if we have a negative for our A value, so a negative A, it means we're going to reflect over the x-axis. And what I mean by reflect is just this right here. If our parent function opens up, then our reflection, our negative in front of our x squared, is going to make it open down. So this one opens up with a positive A. It's going to open down with a negative A. So nice and straightforward. Doesn't matter what else A is. If A is negative, it's going to open down instead of opening up. And we call that switching in how it opens a reflection, specifically over the x-axis. All right. The second transformation we're going to talk about is transforming what our A value actually is. Okay. So if our A changes its actual number, so instead of 1, it becomes 3, or it becomes 1/3, so a whole number or a fraction, it's going to cause a vertical stretch or compression. Okay, now stretch and compression, those are kind of weird words. Let's make it a little simpler. To stretch something, that means it's going to get bigger. To compress something, that means it's going to get smaller. Because stretching, we're stretching it out, kind of like you'd stretch out a rubber band. Compressing, we're compressing it in, kind of like you would compress, squish things together, if that makes sense. Okay, so remember, we're still talking about the A value. So we're talking about a number right here in front of our x squared. Okay, and we're going to talk about 2 different ones because certain A values are going to make us stretch out and certain A values are going to make us compress in. So the first one we're going to talk about is our stretch. So if we look at this function right here, y equals 3x squared, comparing it to our parent function. So our parent function is that nice U shape. What happened to it? Well, at first glance, it looks like it got smaller, but really what we're doing is we stretched it out vertically. So just like you take a rubber band, if you stretched it a little bit more, then that space in between the pieces of the rubber band is going to get smaller. Okay, so the get bigger just means that it's being stretched out. It's stretching out vertically. Okay, so if we have A equals 3, then it's going to be a vertical stretch. Okay, an easier way to state that for in general is if we have an A value that's a number greater than 1, then we're always going to have that vertical stretch. So anytime we have an A value that's bigger than 1, it's going to be a vertical stretch, no matter what. Okay, even if we have like a negative A value, but it's still greater than -1, it would still be that vertical stretch. All right, now our other one, our 1/3. So notice it actually looks like it got bigger, but really it got wider. Okay, so Same idea with that rubber band or that whatever we have, but now we're smushing it together. We're compressing it. Okay. So because of that 1/3, so A equals 1/3 is going to cause a vertical compression. Okay. So if that A value in front is something like a fraction, then it's going to compress it. It's going to smush our parabola compared to our parent function. So see how it takes up this much larger space? That's because it's being compressed vertically. So remember, vertical is this direction, up and down. Okay. Versus horizon, just kind of to help out, is that left to right. Okay. So once again, just to kind of recap over everything, vertical stretch is going to be A values that are greater than 1. So 3, 7, 15, 1.5, anything greater than 1. Vertical compression is going to be A values that are fractions. So specifically, it's going to be A values that are in between 0 and 1 is going to cause that vertical compression. Okay. Now our next one, our C value. So our C value, just kind of looking to the left and the right, it looks like it's going to be just moving our graph around. It's not really going to change the shape of the graph. Okay. So we talked about C before. C is the one that's here inside the parentheses. Now, the biggest weird thing about C is that our C value is always the opposite of what's inside the parentheses. We talked about that in our last set of notes. So our C value is our vertical shift. And by shift, that just means to move. And then vertical is just the same as moving left or right, because we're moving that vertical line of our graph. Okay, so it's a vertical shift, so it's going to be a left or right movement. Okay, for our y equals x minus 3, that's going to shift it to the right by 3. So C was equal to positive 3, which means it moved right by 3. For our other example, we have y is equal to x plus 3. So remember, we take the opposite sign. So instead, C is equal to negative 3, which means we're going to move left by 3. So starting on where our parent function was at the origin, we moved our graph to the left by exactly 3. Okay. So our C value is that vertical shift. It's going to move it left or to the right, and it's always opposite of what's inside the parentheses. So that's the hardest thing about C, is it's the opposite value that's in the parentheses. Okay. Now, last but not least is D. Okay. D is going to be the one that's outside the parentheses. So that's the biggest thing that you can see the difference between C and D. C is inside the parentheses. D is outside the parentheses. And D is going to be a horizontal shift. So once again, we said shift means to move. And this time horizontal means up or down. Okay, so C meant left or right. D means up or down. So pretty easy to remember. Okay, so D is also easier because we don't have to switch the sign for D. So we have x squared plus 3, which means D is equal to 3. If we notice the difference between our parent and our new function, it's shifted up by 3 from the origin. So D equals 3 means we're going to go up by 3. Okay, D equaling negative 3. If we notice instead, comparing to our parent function, we went down from the origin by exactly 3. So D equaling 3, or negative 3, sorry, means we're going to go down by 3. So just as a recap, kind of going over all of them. So a negative in front of the function means it's going to reflect, means instead of it opening up, it's going to open down. Okay, the A value in the front is going to vertically stretch it where it's going to get narrower, or it's going to vertically compress it where it's going to get wider. Whole numbers, so numbers greater than 1, are going to stretch it. Fractions, so numbers less than 1, are going to compress it. Our vertical shift comes from our C value. It's inside the parentheses. You always need to remember to switch the sign. Positive C value means we move to the right. Negative C value means we move to the left. Then last but not least, D value, it's the one outside of the parentheses. It's our horizontal shift, which means up or down. Positive D, which we do not have to change the sign for this one, means up. And negative D means down. All right.